Okay, so when you want to measure the temperature, there are multiple ways of doing the analog ways, digital ways. The simplest analog way is you use a thermometer, but that's not useful for our purposes because we want something which will interface with a microcontroller. So we want the physical quantity to produce some voltage eventually. So here I'm going to show you two methods. One of them is what is known as a resistance-based temperature sensing device. Basically, it senses change in resistance when it's subjected to temperature, and then once there's a change in resistance, you can measure it using voltage divider. There are two devices we'll talk about. A resistance temperature device. It uses metal, like platinum is very expensive, or nickel or copper. There is an expression which tells you how the resistance will change as the temperature is changed. So T0 is the ambient temperature, T is the given temperature which needs to be measured, and R is the resistance as a function of temperature. Here alpha is a material constant. So what will happen is when in normal conditions, T0 is the temperature, and so when you put T equals T0, you'll see that R is R0. The moment you change or increase the temperature, this T minus T0 will be non-zero, which means that R0 will no longer be R, it will be R0. R will not be R0, but it will be some value greater than R0. So you can use the fact that resistance changes to measure the temperature. Here I have three options: platinum, which has a large temperature range, but it's expensive, or nickel or copper, which is cheap, but has limited range. Another way of measuring temperature is what is known as a thermistor. This uses ceramic or polymers. Here, the resistance shows an exponential relationship, unlike here, which is a linear relationship. Here, beta is a constant, and T and T0 are same as before. T0 is ambient, and T is the temperature which needs to be measured. The range for this is typically minus 90 to 130 degrees Celsius. So those are two ways of using a resistance changing device to measure the temperature. Here's another way of doing it. There's a IC you can buy. It's the LM35C IC. There's a VC, ground, and Vout, just three terminals. You connect this to a voltage source, and Vout measures the voltage. So what I found is that these need to be calibrated before use. So what you'll do is you will hook this up in ambient conditions. You'll know the temperature, and then whatever Vout you get needs to be correlated with the ambient temperature. And then when the temperature increases, Vout will change, and you can have some scale which comes from the calibration, which will tell you how the voltage is related to the change in temperature. Now, what do they have inside them is a transistor. There's a property of transistor, which is when the temperature changes, the forward voltage of the PN junction changes. And that's fact is exploited to create these ICs.